Okay, let's do the second one, the mole ice table. Try to explain what happened in the masses. Why didn't 1 plus 1 gram equal 2? So, if we convert all those grams into moles, what you'll end up with is that the 1 gram of zinc is 0.0153 moles, and the moles of iodine is 0.00394 moles, and we have zeros. Okay. So what that tells us is that in 1 gram of each of those things, we end up with way less iodines. And the real reason, let me use my googly eyes to help, is that, oh, I'm losing everything. Here are my googly eyes. For 1 gram, zinc is a lot lighter than iodine. So for the same amount, you're going to end up with a lot of zinc atoms. The same mass, you're going to have a lot of zinc. But for the same mass, iodine is much more massive. Its molar mass is like 230 something. We only end up with less googly eyes. And the way the reaction goes is that zinc iodide really just needs 1 of these and 2 of these. So you'll see how quickly the number of zinc molecules chew up the iodine. The iodine runs out really quickly because there's less of them. So here it is, 1 plus 1 I2 gives you 1 zinc iodide. So this really kind of like proves to us the argument of the mole ratios, in that you need 1 of these to react with 1 of those to make 1 of those. So chemistry, 1 plus 1 equals 1, which is really weird when you think about it, but whatever. So what happens is you can only make as many sandwiches as cheese you have, so this is our limiting reactant. So this is the one that runs out first, and we can totally see that here. So this is, all of this is going to be gone, 0.00394, and that ends up with 0 iodine in the end. The zinc, well, we only need 1 of the, for every 1 of these, we need 1 I2, so it's the same number, and this is the one that runs out first. So we have to subtract the same number, 394, because we're not going to react more of this than there is this that's there. I mean, this is only 1 slice of cheese. You have 1,000 pieces of bread, you can only make 1 sandwich, or 0.00394 sandwiches. So subtract these, 0.0153 minus this, and you get some number. Of course, I don't feel like doing math. How sad. Oh, there it is, 0.0. Sorry, Miles Chen. He was always getting mad at me for needing a calculator. So 0.0114 moles of zinc. And remember, the recipe for 1 of these reacts with 1 of these to make 1 of these. The moles that react, so 0.00394 moles of this plus reacts with 0.00394 moles of this, 1 and 1, that'll make 1 of these, 0.00394 moles, 0.00394 moles. So really what that tells us is that the limiting reactant is iodine. We figured it out through the molar masses, how many of the particles we had. And it's the one that runs out first, so it dictates how much product we have. It's a 1-to-1-to-1 ratio, so for every 1 of these reacts with 1 of those, gives you 1 of these, or 0.00394 reacts with 0.00394 and gives you 0.00394. And the really cool thing is that when we convert this many moles of zinc to grams of zinc, this turns out to be 0.75 grams of zinc, which is our data, and this turns out to be about 1.25 grams of zinc iodide, which I think is pretty cool. So this model explains our masses. So our data can be explained by thinking in terms of moles, not just masses as additive. Okay, hopefully that helps.